This presentation is being created for Mr. Roy's Understanding Ourselves Through Physics course. I have chosen to do my vlog based on the beginning of a trip. From the very beginning of the airport, you can see physics in action. One of the very first examples of physics that you'll encounter are metal detectors. They enable security within the airport to identify any forms of metal you may be carrying on your person. This is to help reduce the amount of security issues the airport could experience. The basic science behind metal detectors uses laws that Mr. James Clerk Maxwell discovered. Walk-through metal detectors use pulse induction technology, which sends pulses of current through the coils of wire, creating short magnetic fields. When a piece of metal enters, it creates a reflective magnetic field. The way that this field reacts with the coil causes an alarm to sound and alerts security that there's a problem. To enhance security measures even further, airports have implemented new technology to provide more detailed imagery, which enables them to identify risks that may be hidden even further than traditionally seen. There are two different types: backscatter and millimeter wave machines. Millimeter waves are more commonly used because they use electromagnetism instead of radiation. It uses electromagnetic waves that bounce off the body to create an image, allowing security to see inside a person. The low-level radio frequencies can provide a good image without the additional health risks. A common problem amongst travelers is wobbly suitcases. As you're rushing to get to the terminal you need to be in, your suitcase starts going awry and begins to turn itself over. Studies have been performed on the issue and have laid out the scientific method for this problem. The question was how to prevent the wobbling of the suitcase. Experiments were performed with a rolling suitcase and a treadmill. The speed of the treadmill and the weight of the suitcase were changed throughout the experiment to identify what conditions are better for the suitcase and its control. The motion, masses, and speeds were observed and recorded. The results showed that the faster the person moved, the less the suitcase wobbled. The faster the suitcase moved, the more energy needed to disrupt the suitcase path. It is vital that you buckle your seatbelt prior to the flight's departure. The seatbelt can help keep you safe. This can be understood by considering Newton's first law. It says that an object is going to stay in motion unless it's acted upon by an outside force. If we consider that force is equal to mass times the acceleration, as we see in Newton's second law, we can see that the force of an airplane crash can be devastating, and it's safer we use our seatbelts at all times. Flying uses all three of Newton's laws of motions. There are four forces involved with air flight: thrust, lift, drag, and weight. Thrust counteracts drag and lift works to overcome weight to keep the airplane in flight. One thing you'll want to consider as you journey up in the air is what is the weather going to be like as you take your journey. Weather is the most common application of meteorology. It consists of dynamics and thermodynamics. As mentioned before, objects at rest won't move on their own. There must be some kind of push or pull. Newton's second law states that the change in motion is directly related to the applied force in the direction it occurs. Air interacts with the natural gases of the atmosphere to create our weather patterns that we see. As you get out of the airport, you may realize that you are not fully sure which way you need to go to get to your hotel. You feel nervous asking strangers, so you can rely on a global position system to direct you where you need to go. This is a great example of a technology given to us by quantum mechanics. A GPS uses satellites to determine location and compare the current position to the desired location using general relativity to create the directions. When you get to your hotel, you may choose to use a luggage cart because it's a lot easier than hauling them upstairs and you just want to get to your room. Luggage carts utilize Newton's second law by the fact that the force needed to push the cart is a mass times how fast you want to move. The heavier the cart is, the harder you must push and the longer it's going to take you. I personally have always gotten such a thrill out of elevators, which has only been enhanced by my vertigo that I've developed over the years. As you enter an elevator, you feel completely normal, but as the elevator begins to rise, you feel a sense of being heavier. As you go down, you feel almost weightless. The sensation can be attributed to Newton's second law, which states that the force felt on an object is equal to mass times the acceleration. As you wake up in the hotel room in the morning, you decide you want a piece of toast for breakfast. So you go in, put the toast in the toaster, and push down the lever. You begin to see the coils within the toaster turn bright red, and you can feel the heat begin to come off of the toaster. Toasters use infrared radiation to heat the toast up, which is what you see when you see the coils lighting up inside the toaster. The electricity goes in through the power plug and excites the electrons throughout the coils, which makes them move throughout the wires, which heats up the elements and helps cook the toast. Now you're able to start your day and begin your adventure. Thank you for your time.